Okay, first of all, let's all try to understand what this question wants us to do. It says show. Now, when it says show, it's an AO3 question, so it's a harder kind of question. Show that the roots. Now, what's the meaning of roots? Some of you still don't know. The roots means the solution. That means when I solve this, the solutions are real. What do you mean by real? Real means you are not square rooting negative number when you apply this formula. Remember I told you this discriminant expression came from this quadratic formula. Okay, so what they're saying is they're not saying whether one root or two roots. It can be equal roots, which means this is 0, or it can be two real and distinct roots, which means this is greater than 0. Okay, so because they just use the word real, alright, so your condition later has to be b squared minus 4ac greater or equal to 0 lah. Okay, so in this particular question you will find that it is not say very well set. Okay, because not really can be equals to 0. Alright, so by right this question they should set it as has two real and distinct roots lah. Okay, later you will know what I mean. Okay, but first thing you need to do is, as I told you, when quadratic equations are not in the form ax squared plus bx plus c, you must change it into the form ax squared plus bx plus c. And I know you are very good at expansion, but don't go and expand this. Why? Because this p, when they say it like that, right, it means p is a constant. Constant means a number, a fixed number. Okay, the variable is the x. So when they say the roots of this equation are real, they are referring to the x, not the p. Okay, because they already tell you that p are all real. Okay, so it's a bit hard to understand because you are just starting out, but you'll get a hang of it lah. So this is a, this is b, and c is this whole thing. So you can see when I so-called remove this and make this side 0, right? What I've done is I minus 5 both sides, then this 5 disappear, this minus 5 appears here, plus 2p both sides, then I get this. Okay, then I use discriminant. Okay, those who write this or you write this, it's totally 0 because in this question, right, they say show, so you cannot conclude this from the start. You cannot conclude. You have to instead find what is b squared minus 4ac. Okay, so that's what I'm doing here, b squared minus 4ac. Now those of you who cannot expand, please learn it now. Okay, square this, get this, square this, get this. It's always a plus. Then this times 2. Okay, if there's a minus here, then it's minus times plus, then it's minus. Okay, if this is plus, then there's a minus here, then it's still minus. Okay, but because both are plus, so plus times plus is still plus. Okay, and when you work it out, you will find that it gives you this expression here, the b squared minus 4ac. Alright, so you don't write this. Okay, what do you do after this? As per the previous video, you need to analyze this. And how do you analyze this? The only way to analyze is to use a completed square. Alright, so the doggy stays, and you see I write the template here, something square minus something. You go and check the homework that I returned you, or I think there's one stack I haven't returned, it's in my bag. Return you tomorrow. Many of you forget to put the square, or you put this as plus instead of minus. So can you follow me and use this template? Okay, then you won't make careless mistakes like this. Okay, divide by 2, whatever this number here, you divide by 2, and then you minus the square of this, you get this. Alright, and remember this minus belongs to the 9, so it's minus 9 plus 21, which gives you 12. Okay, so this is your completed square. Now, are we done yet? we are not done yet. We have completed the square. Why do we want to complete the square? Because it's not possible to analyze this, but it is possible to analyze this completed square. Why? Because we know that a perfect square, which is this part here, is always greater or equal to 0. Yeah, so you continue working, you will find that this expression here, which is this one, the equivalent of this one, okay, is always greater than or equal to this one here, b square minus 4ac. So I'm going to write here b square minus 4ac. Now you must state this. You must state that the discriminant is always greater than 0. Okay? Yeah, so this is how you should do it. Okay, now why do I say that this question is not well set? Because actually when we say real, right, and as I explained earlier, it should be b square minus 4ac either greater or equal to 0, right? But if you see in this case, is it possible for this b square minus 4ac to be equal to 0? No, it is not possible. Okay, so actually it should be roots are real and distinct. Okay, I think this will be less confusing for you. Alright, you see what I mean? There's no way this thing here can be equals to 0. This thing here, p bracket bracket p minus 3, right, square, then plus 12. There's no way this thing can be equal to 0. You see what I mean? You put p inside here, this is 0, so the smallest is actually 12. So this, you can only conclude that it's greater than 0. That means it's positive. What I'm trying to say here, this statement here is important because you are saying that this b square minus 4ac is positive. And when it's positive, there are two answers. Okay, when you square root this, there's an answer here. So you got a plus answer, you got a minus answer. So there are two answers. Alright?